Go ahead.
Global warming's effects on hurricanes in Florida, presented by Landon Abrams, Kyle Andrews, Luca McLean, and Willie Snooch. Our question. As hurricanes become more intense and frequent, their effects on Florida's coast are becoming increasingly severe. Rising ocean temperatures provide these storms with more energy, intensifying winds, rainfall, and storm surges. This leads to catastrophic coastal flooding, beach erosion, and widespread destruction of homes, businesses, and infrastructure. Natural barriers such as wetlands and coral reefs, which help protect the coast, are being damaged, making future hurricanes even more destructive. According to the Environmental Defense Fund, hurricanes in Florida are becoming more dangerous than ever before. Our question is, as hurricanes become more frequent due to global warming, what are their effects on Florida's coast? Our question is important because understanding these impacts allow us to find better ways to protect Florida's coastline residents and habitats. With more frequent hurricanes, communities face increased risks of displacement, financial strain, and long-term environmental damage. By studying these effects, we can improve disaster preparedness, strengthen infrastructure, and create sustainable solutions to reduce future devastation. Hurricanes are becoming a major threat to Florida, with storms like Hurricane Ian and others in recent years showing just how devastating they can really be. These powerful storms bring severe flooding, destructive winds, and massive storm surges that wipe out homes, businesses, and vital infrastructure. Residents are forced to evacuate more frequently, and rebuilding efforts become more expensive with each passing year. Beyond property damage, ecosystems are devastated, fresh water sources are contaminated, and insurance premiums rise. With each hurricane season, Florida faces the constant cycle of destruction and recovery. As these storms grow more intense and frequent, it's crucial to take actions now to protect communities from the next major hurricane. Increasing frequency of hurricanes, according to Dr. Roy Spencer. Dr. Roy Spencer is a climatologist and has analyzed historical hurricane data and observed an upward trend in the last couple of decades of major hurricanes striking Florida since the 1900s. He notes that while recent decades have seen much more active hurricanes, as you can see in the graph, Dr. Spencer emphasizes that natural variability plays a significant role in hurricane patterns and attributes this growth with the effects of global warming. Increasing global temperature according to climate.gov. According to climate.gov, Earth's average surface temperature has risen by approximately 2 degrees Fahrenheit or 1 degree Celsius since 1880, with the rate of warming more than doubling since 1981. This increase is primarily due to hurricane activities such as burning fossil fuels, which elevate greenhouse gas levels in the atmosphere. But these rising temperatures contribute to the devastating hurricanes we know, posing a significant challenge to Florida's ecosystem and ecosystems worldwide.
There are two possible solutions to the problem. The first one is coastal infrastructure resilience. There are three parts to this: reinforcing buildings, making flood barriers, and making advanced stormwater systems. Reinforcing buildings will help to keep the bases stronger when the floods come in, but flood barriers can help to push the water back so it doesn't overflow into the cities. But if water does overflow into the cities, then advanced stormwater systems can help to drain the water. Dr. Cobb, an oceanographer and climate scientist from Rutgers University, says investing in stronger coastal infrastructure, including flood barriers and stormwater systems, is a proven way to mitigate damage from extreme weather events. The Federal Emergency Management Agency has already started to allocate funds for states to improve infrastructure in hurricane-prone areas. The U.S. Army Corps of Engineers also states that structural measures reduce the probability of flooding. These measures include flood-proofing structures, flood warning systems, seawalls, and levees. There are some limitations though. The primary one is cost. Reinforcing buildings to be hurricane resistant or making new buildings or structures can be very expensive. Jill DeWitt, Director of Coastal Resistant Programs from the Nature Conservancy, says retrofitting buildings and infrastructure to be hurricane resistant is undeniably costly. The challenge is ensuring that funding and resources are available to sustain these efforts long term, especially for underserved communities. Additionally, the solution does not address the broader environmental issues like sea level rise and ecosystem damage, which contribute to the issue. Dr. Robert G. Wesson, an environmental policy expert, says improving infrastructure alone is not enough to combat the long-term threats posed by climate change. Addressing sea level rise, habitat destruction, and the environmental impacts of storms requires a holistic approach that goes beyond buildings and flood barriers. Building codes may also not be universally enforced or effective in all regions, which will leave some areas vulnerable and exposed to the floods and hurricanes.
Solution 2, ecosystem restoration. As the University of Massachusetts states on their website, quote, to protect coastal cities from hurricanes, state governments must invest in green infrastructure, specifically in restoring salt marshes. Salt marshes mitigate storm surge, a destructive aspect of hurricanes, and represent a cost-effective hurricane defense solution compared to other solutions. As going off of this quote, other studies have proven that these coastal ecosystems can defend against storm surges by up to 50%. It is also a very cost-effective method, as all that is required is relocating plants from one area to another. Efforts have been made in Florida similar to those that have been made in Louisiana. Limitations. Ecosystem restoration is a very time-consuming process. And all this progress can be lost very easily. So 3 decades worth of work on ecosystem restoration can be completely blown away by one major hurricane. And even still, this approach might not be enough to protect heavily urbanized areas.
All right, so conclusion. Coastal infrastructure resilience provides immediate protection, can be customized and prevents major damage. However, it is extremely costly and may harm the environment. On the other hand, ecosystem restoration is inexpensive and cost-effective, good for the environment, and is flexible. However, it takes time, needs constant care, and does not fully protect areas. So the best solution we choose was solution 1. This is because it's vital for protecting coastal communities from increased storm and flood risks. And according to the World Bank, investing in resilient infrastructure can reduce disaster-related losses up to 50%. The first major reason is its immediate protection and provides direct safety. According to the FEMA, areas with reinforced infrastructure experience less damage and fewer casualties during storms like after Hurricane Katrina, while ecosystem restoration takes decades and won't protect against extreme hurricanes. Next is its critical infrastructure safety, where it ensures vital services such as water, power, and hospitals remain operational and open during and after storms. And according to the NIAC, resilient infrastructure helps speed up recovery as well as ensure public safety. However, on the other hand, restoration is actually not designed to protect critical infrastructure at all. Finally is scalability and adaptability. Coastal infrastructure resilience is tailored to regional needs and can be customized based on vulnerability. Flexibility allows for urban areas to focus on pressing needs. An example of this is the Miami-Dade County Climate Change Action Plan in 2017, where stormwater systems were built in order to handle the frequent flooding. On the other hand, while ecosystem restoration is limited by land and environmental degradation. And according to the EPA, in 2020, the Everglades Restoration Project, which aims to reduce flooding risks, has struggled due to land availability. Also, in 2021, in Louisiana, efforts to restore wetlands have faced setbacks due to land loss from erosion. is our website.
Wow.